So the next talk is by Richard Yen, okay, from EDB, from Enterprise DB. It's about logging best practices in PostgreSQL. Thank you, Richard. Hi, welcome.
Hi, thank you. All right, let me share my screen. Okay. Oh, oops. Are you able to see the presentation?
Yes.
Okay, great.
Yeah.
All right. Hi, welcome to Scaling the Wall of Text, best practices for logging in PostgreSQL. My name is Richard, and I just wanted to share with you some of my experiences and something that I feel like is a very important topic that many people seem to overlook. I think many people, when you deploy a database, the priorities are performance and reliability and recoverability. But in terms of logging, that tends to be kind of a second, like a later thought. So just a quick little bit about myself. I'm a support engineer at Enterprise DB, and I support several of our customers, and I've been using PostgreSQL since version 7.4. So hopefully my experiences might have some kind of positive effect in your later on in this talk. Just to give you an idea of what we encounter in support, we encounter a variety of issues, anything ranging from poor query performance to a crashed database, or just even having difficulty upgrading to a new database version. As much as this list displays, it's just a very small fraction of the things that we encounter. And all this is just to say that bad stuff happens. And, bad stuff happens, things crash, things don't work sometimes. And I think that's true in life and not just in the database world. But the road to recovery, it doesn't have to be bad. And the way that you get to recovery is by having the right resources. Now, I don't know the viewers out there, if you guys are using database, how do you get help? Maybe you get help from a coworker, or you get help from some other support vendor. And I think when you do ask for help, I think you do need to have, you do need to be prepared with three items, right? First, you need to have your configuration ready, so that way the person helping you will have an idea of what the environment's like and what the settings are. They might be able to help you identify maybe like a poorly configured setting, or maybe some kind of typo in the configuration, something like that. You also want to provide a very thorough and accurate description of your symptoms. That way they know what they're looking for. If it's like a crashed database, or if it's a query that's returning the wrong kind of information, you'll want to describe that very well. And then finally, you want to have your logs ready. So that way the person can go through and review the history of the database system and help you identify what the problems are. I think as a support engineer, I can tell you that one of the first things that we ask for is logs. And oftentimes when our customers aren't able to provide those logs, we end up having to go through extra communications and extra time to get those logging set up, so that way they can reproduce the issue and then actually give us the logs that we need, so that we can help them deal with the situation. So I think just to kind of highlight what the log is able to help you with, the log is able to give you this kind of information, as you can see on the slide. It can tell you things like when a query started and finished, how long it took. It can print out error messages, just things that would indicate some kind of corruption, or something that would show you like a hint as to what is wrong with the database. So the more you log, you actually it actually benefits you as a administrator or as an organization. Having more log means you're going to be able to diagnose and get to the root cause faster. And once you get to the root cause, you're able to recover quicker. And when you're able to recover quicker, the people using your database are actually going to be, experience less interruption, and they'll be happier. And then that also translates to less stress for us as DBAs and support engineers. And it also helps you audit better to kind of get an idea of what happened in the past, and also it helps you predict the future. Actually, as you look at the warnings that are being printed out, you get a better idea of how to plan for your capacity in the future. So the bottom line, having more logs means you will actually save both time and money, which is great for your business. So now that I've established how important a log file is, let's look at what Postgres provides in terms of logging features. So if you look at a postgresql.conf file, you'll see that it's split up into 3 sections for logging parameters. First, it's the where to log section, then it's the when to log section, and then finally it's the what to log section. So I'm going to go through each of these sections with you just to kind of give you some tips and explanations of what some of these parameters are. I know there's a lot of them, so it might be kind of intimidating to look at them, but I think after you go through this presentation, you'll actually get a better idea of what to focus on. Okay, so first of all, where to log. Where to log. So the first thing you have to decide is what is the log destination? Is it going to be the std error? Is it going to be syslog or some other logging mechanism? By default, it's std error. Some people are using, I've seen use syslog, but by and large, most people just stick with std error, which means that the log file gets printed in plain text format into a file on disk. You do need to turn logging collector on, otherwise it won't print anything that useful. So by default it's on, so let's just leave it on. Now the first important decision that you need to make as a DBA is to decide where log directory is going to be. By default, it goes into pgData, but what I would recommend is that you use a custom partition. So in the same way that we Postgres users recommend putting your wall files into a separate partition, you should also put your log directory into a separate partition as well, because that way you'll reduce the contention on disk. So when you're logging a lot of stuff into your log files, you're not competing for resources as you're writing to the database. And then at the same time, if you have your log directory on a separate partition, you can actually, if the partition fills up, you don't end up having a really long downtime. Is there a question?
No.
Oh, okay. All right. I heard something. Okay. So that's log directory. Yeah, definitely use a separate partition. The next decision that you'll need to make is to decide what your log file name is. As you can see on the screen, Postgres default is postgresql-year, month, day, hour, minute, second .log. So every time you start the database or restart it, you're going to get a new file, and it's going to have the latest timestamp. Some people find that to be a bit cumbersome because it's not really deterministic, what the file name is going to be, and it could be kind of messy looking with a bunch of numbers that represent a timestamp. So some people actually change it to represent the day of the week. So like postgresql.monday to postgresql.tuesday, and so on, which is great. I mean, some people, it's good for some organizations. But if you do that, I think you need to be warned that if you need to make sure log truncate on rotation, which is the bottom item on that list, that it should be turned off. Because what would happen is, suppose today is Thursday and you're logging to Thursday, and then tomorrow is Friday, you'll log to Friday, and then you come back around, and the next Thursday, that file gets open again. And if log truncate on rotation is on, then all those files, all those logs are going to get truncated, and you'll end up with a brand new Thursday file, which means you're going to lose last Thursday's logging, which would not be very good if you're trying to audit your database. So be sure to turn the log truncated on rotation off, and name the file however you need to. Right now, the log rotation age default is set to 1 day. So even if you have a file name that has a timestamp, it will actually at midnight at midnight is going to create a new file for you. So you can either turn that on or off based on your needs. Okay, so so that's where to log. Okay, so let's move on to when to log. When to log is represented by these parameters. And the bottom two, they're relatively new. I haven't actually had to work with them with our customers, really. But those features are actually pretty useful, and I'll go over them briefly with you. So the first two ones, logmin messages and logmin error statement, these parameters determine at what sensitivity to log your to print messages into your database log. Now, logmin messages, based on the debug info warning and notice, it will print a message that that kind of indicates, oh, what's going on with the database. Logmin error statement will use the same list of levels, but that determines at what sensitivity to print not just the message, but also the query that caused that message to show up. So for example, like warning at the default, if logmin messages is set to warning, any warning message will get printed to your log file, and then any warning message will also print out whatever SQL command was used to print that warning. Now, my general guidance is to leave it at warning. Don't turn it up to notice or info or debug. I've seen many customers just put it up to debug 1 or debug 2, and that's actually not very useful because those levels are generally used for developers. So they're trying to debug and trying to figure out where in their code, what code path they're hitting. And what it ends up doing for the customer is it just creates a lot of noise, and it's hard to make sense of what's getting logged. So what I would recommend is just set to warning unless somebody advises you to turn it up. The nice thing about these parameters is that you don't need to restart the database to change it. You can just hop or reload the database, and then those that sensitivity will get changed. Okay, so the next two items were log min duration sample and also log min duration statement. Now, log min duration sample is new in version 13. It gets coupled with log statement sample rate. And what this does is it basically limits which samples queries get logged. Sometimes you might have an ORM that's just printing out bunches of queries, and it just kind of makes for a lot of noise in the log. And what this parameter does is that it limits that the printing of those queries so that you don't get so much noise. Which when it comes to auditing, it might not be a good idea. But if you know that you're going to get the same query over and over and over again, why not print just a few of them instead of printing them all? Because it just creates too much noise. So in general, I would turn that off. But unless you really need it and you're getting too much noise, you can kind of filter it down with this parameter. Logmin duration statement is one of the most widely used parameters amongst database administrators. What this does is if the statement took so much time, it will print that statement to the log. So that way oh, this particular query took a long time. So it basically logs the queries that are considered slow in your application. Now, what I do want to point out to you is that log min duration statement can be confused with log statement and log duration. So I'm going to do a little quick aside to kind of describe the differences for you. So first, log min duration statement versus log duration. Log duration, it only logs the time it took for a query to run. So actually, so what you end up seeing is you'll see the logline prefix plus a duration. And that's not very useful, but I think some people might want to use that to kind of get an idea of any kind of patterns of, you know, the queries getting longer or the average query runtime on the system based on how busy it is. So log duration can be useful for some people, but usually I haven't found it too useful. Log min duration statement, however, will log the time it took for the query to run, just like log duration, but then it also logs a query. Now, the thing is that it only applies to the queries exceeding that threshold. So if you set the log min duration statement to 1 second, it will only print the query and the time for anything that took over 1 second. So if anything is less than 1 second, you're not going to get anything. So you may need to turn log duration on or off based on your need to gather statistics for high workload environments, but that's just, I'm just going to describe that to you, and you'll have to decide what to set it to as a on your own. Now, moving on to log duration statement versus log statement. Now, log statement is a parameter where you can always print the queries that are being issued. You can set it to none, which is never log the statement. You can set it to all, which is log all statements, or you can set it to mod, which basically only logs inserts, updates, and deletes, so that we can do some auditing later on. You can also set it to log only DDL. So that's what log statement does. Now, how is that different from log min duration statement? Now, I think this is something that several of our customers have not actually noticed in the past. So hopefully, as I describe this to you, this kind of gives you an idea of how you want to set this. Log min duration statement will only log the statement after the query has finished. So once the query is done, it prints, you know, this statement has run and it took this much time. However, log statement, it will print the statement before the query is executed. And it says, basically saying, this query is about to execute, and it actually logs all the parameters, if there's any placeholders, things like that. The nice thing about that is if a statement causes your database to crash, log statement would have printed that for you. And then when you go to look at your logs and find out what crashed your database, you would see the query that was issued. If you didn't have it on and you only had log min duration statement on, then you would not get anything. You only know that your database crashed, and you wouldn't know why. So log statement can be very useful in terms of finding out, you know, what caused some kind of database problem. Okay. The final two parameters that were in the when to log section. These are basically the sample rate parameters that helps you filter out, you know, extra noise. The log transaction sample rate actually sounds pretty interesting, because what it would be nice, what it basically does is it randomly samples transactions. So for some transactions, it will log all the queries per transaction from the begin to the commit or the begin to the rollback. Now, that would be useful because if you're trying to find out what your ORM is generating or your driver is generating, this would be a way to kind of get an idea of what that's doing. So that's a good parameter to kind of tinker with if you are trying to work with like Django or Hibernate or something like that. Okay, so that's so I've covered everything in the when to log section. Now, finally, the what to log section. This is the largest section. It has a lot of on and off variables, and I think this one it does warrant a bit of going through. So so log out of vacuum min duration. This is a similar to the log min duration statement. After a certain threshold, it will print out all the out of vacuum statistics. This is actually very useful, and I'll kind of go through that a little bit later in one of my examples. Log checkpoints, I would recommend turning that on, because you would want to know when the checkpoints happened and how long they took, because that would actually help you get an idea of why there was some kind of IO contention at a certain time of the day. Maybe it coincided with the checkpoint, and this would reveal that for you. Log connections, I would recommend turning that on as well. Log disconnections, turn that on. These will help you get an idea of what incoming connection requests happen, so that way you can do some auditing in case there's some kind of security risk. Log duration, just like I mentioned earlier, I would recommend just leaving that off. If you need to turn it on, you don't have to worry about restarting the database. You can do that with a reload. Log error verbosity. What I would recommend is keeping it at the default. I've seen some customers set it to verbose, which is actually not very useful, because the way that log error verbosity works is that once a log message is printed, it actually prints the line of the code that called that print message, which it could be useful in terms of trying to diagnose or debug a particular issue, but in terms of finding out what the like a performance issue or a some kind of load related issue, it actually creates extra noise that makes it hard to sift through. So I would just leave it at default unless you absolutely need to set it to verbose. Log host name, I would turn that on, and that would help you translate all the IP addresses to actual host names. You can turn it to off if you want to just keep it with IP addresses. Log lock waits, this is actually very useful, so turn that on. It would actually tell you which processes are waiting for locks, and it would actually tell you how long they've been waiting and how long the lock wait queue is. So if you actually see you'll see this in one of my later examples, but if you kind of see how long the wait queue is, you can kind of get an idea of how much load there is on the database. Log recovery conflict waits. I haven't actually had to use this, but I would just keep it on just for auditing purposes. The next two, log parameter max length, I haven't actually used those because those are relatively new. Log statement, keep that at DDL for the auditing purpose. You can turn those on up and down with the reload as well, so you can pretty quickly change those. Log replication commands, I would just keep that off. It could be extra noise that is hard to read. Log temp files, turn on, and log time zone, you can you set that to whatever time zone you're working in. Okay, so the one I highlighted in red is log line prefix. This is the most important parameter in the logging features that Postgres provides. This is the recommended log line prefix that I have for you, and I'll have this at the final slide. But the reason why I wanted to highlight this parameter is because many of our customers, we've noticed that they just leave it at the default. So as of version 10, it defaults to M and P, which is basically timestamp and backend PID. Before version 10, 9.6 and earlier, is blank. And what's interesting is that of several of the customers that we looked at, 38% of them only log 2 attributes, which basically means they only log timestamp and backend PID. What does logline prefix do? Basically, what it will do is every line printed in your in your log is going to have this this prefix. So M is for timestamp, P is for PID, L is for the line, like the occurrence of that PID in sequence, and then it also will print the transaction ID, username, database name, application name, and client IP address or host name. Now, there's actually other parameters that you can use. Use it if you use those extra parameters, extra flags if you want. But I think the reason why I want to encourage everyone to use more of these flags is that it gives greater clarity. And what it ends up doing is actually gives you more control over the filtering and sorting and grouping of the log lines as you do your analysis or auditing. Just to give you an idea of what this would look like. So here's a sample of a log that I generated. Now, notice how there's nothing before the at the beginning, no prefix. This was taken from a version 9.6 database which basically has no logline prefix. Now, if you look through it, you can just see there's a bunch of statements, and suddenly there's some errors and you don't know why. Now, let's say we actually bumped up to version 10 or above. We're going to see a timestamp, right? So now you can say, okay, now I can say, okay, there was an error that started happening at 11:15, 11:15 seconds, which, that's better than nothing. Now I know when the error started happening. But we can actually, now that we have this timestamp and PID, we can actually sort. And when we sort, we can actually order them by their PID, which is the fourth column here. And then it's still hard to kind of read because it's just a wall of text. But let's say I color code this for you. Now you can notice here at the very bottom, this red line, this one particular PID, it issued a drop table, and that's the reason why we see that error. So the problem is here is with the timestamp and the PID, that's still not enough to figure out what exactly happened. You just know something got dropped, but you don't know what. You don't know who issued it. You don't know where the connection came from. And that's why we want to set logline prefix to something longer with a little bit more information. So here's an example of the same log with logline prefix with all those parameters that I shared here. So it's a bit intimidating to look at because there's so much text. Now, once again, let's say I sorted by PID, right? So I sorted by PID, and then now I can identify, oh, okay. So there was a connection that came in from this particular IP address, and then that particular IP address issued the drop table statements. And there we go. Now we can actually go and find out, who it is or what app it was at that IP address that issued the statement and caused catastrophic damage. So I think now that I've kind of explained to you where to log, when to log, and what to log, you kind of I trust that you guys are a lot more empowered and equipped to do to configure your logging. Just to kind of give you an idea of what are the things to look for, right? You got your log configured, but then what do you look for in the log? So these next few slides I'm going to go through will kind of highlight that for you. Okay, so let's see what to look for. So look for particular logging levels. I think many of the monitoring software will actually filter and look for these logging levels, and these are the same logging levels that you see in the logmin error statement. So warning, you want to look for the word warning in all caps. It's not necessarily an urgent or actionable thing. It could be a warning saying, hey, you're running out of transaction ID, you need a vacuum. It could be a warning that something, some other potentially unhappy situations may come. So look for those and proactively decide what to do with those warnings. You should also look for errors. Now, errors are just simply failures to execute a command. They oftentimes it would just be a syntax error. Maybe the table doesn't exist. It's a Postgres. The Postgres community or the Postgres code defines an error as a statement ending situation, right? The next level up would be fatal. Look for the word fatal in all caps. Now, that would be a session ending situation. So the session was ended because of some kind of error. So like either a wrong password or the wrong auth level, or something else like maybe a broken network connection. So that would end the session, and that would print in a fatal message into your log. Finally, what else to look for is a panic statement. Panic in all caps basically means something really bad happened in your database. Maybe it was a seg fault, maybe it was it encountered some kind of corruption in a table. And what Postgres will do is it will actually terminate all sessions for safety, and so that way you don't corrupt the shared memory. So if you see the word panic in your logs, you'll know that something was very wrong that caused Postgres to abort everything and shut down. So those are the keywords that you would want to look for. Now, some common issues that these keywords could indicate. So like for example, if you look through your logs and then based on your timestamp, you see a spike in fatal messages. That often correlates to maybe like a misconfigured application. So somebody, wrote a program and then they deployed it, and suddenly you start getting these fatal messages. That's probably because whoever deployed that program, set a wrong password or something like that. A spike in error messages can either correlate to an application bug. If you deploy a program and you suddenly see error, missing table, or this table doesn't exist, then you can kind of get an idea, okay, maybe there's an application bug. It could also indicate broken replication, like the queries cannot execute because the replication hasn't completed, there's a lag. Look also for the auto vacuum. So log min auto vacuum, duration. So when auto vacuum took a long time, you'll actually find a message about all the auto vacuum statistics, and that will kind of give you an idea of what else to look for. Don't ignore the detail and hint messages. Those are actually very useful as well. Okay, so just kind of to point out like what a hint would look like. So here's a log entry with a hint. So if you see here, it says, warning, database Postgres must be vacuumed within however many transactions. Oops. Okay, here we go. That warning is followed by a hint, right? To avoid a database shutdown, execute a database-wide vacuum in that database. And then, so basically, if you are able to issue that vacuum, you're going to be able to recover some of your transaction IDs. And notice just underneath it, it also says you might also need to commit a rollback prepared transaction. Many of our customers have failed to see that line, and we've actually found several situations where like a long-running transaction was never committed or rolled back. So pay special attention to these hints. They actually give you idea of what to do to recover from your issues. Next, what else to look for? Patterns. Since most deployments of Postgres are done on Linux, the Linux command line tools can be very, very useful. So here you can see an example of grep and awk being used. You can use sed as well. And basically what I've done is I've taken a log and used these commands and I grouped them. And this was because a customer had complained about like a service outage, but they didn't know what time. And so then when we looked here, we actually had the log connections turned on. So we looked for all the connections that we received, and we found that at 2:47, there was a dip from 80 to 21 connections. So that was the point at which we started looking at, what was the cause of the service outage. So definitely use your Linux bash commands to manipulate the log, sort them, group them, filter them, and that'll kind of give you an idea of, kind of help you with the next steps in the diagnosis. See, if I mentioned looking for a spike in fatal messages. So as you can see, this screenshot shows a lot of fatal messages. These fatal messages have something to do with the database starting up. And sometimes this actually gets kind of annoying, and it's because the database is trying to recover. It had crashed. And then even though it's recovering, the application has not been turned off. And because the application has not been turned off, it just keeps repeatedly trying to connect to the database. And the database keeps saying, no, I cannot let you in because the database is starting up. So I think just from this example, what I would recommend, if you have an outage, you should talk to your application team and tell them to turn off their application, turn off their web servers, so that way you don't clog up the database logs with these messages. And actually, it could even slow down the recovery process. This particular example, it says, warning, there is no transaction in progress. And you can also see that it says unexpected EOF on client connection. Now, what does this mean, right? You might see this. Basically, what this means is that the application probably crashed and disconnected without telling Postgres. So basically, the connection was severed, whether it's from a network issue or from an application crash. And Postgres doesn't know what to do with this open transaction. So then it prints out this messages, and then it aborts the transaction. The no transaction in progress, it could probably appear because somebody issued commit or rollback when there wasn't a transaction. So that could be a bug as well. Some applications will fail to begin a transaction and just issue a bunch of queries and then do a rollback. So that would be a very bad bug to have, because you don't start your transaction, you do a lot of inserts and deletes, and then you try to roll it back, but then you can't because you never actually started the transaction. So if you see these, you should talk to your application team and tell them to look for some kind of bug. Okay, this is a very common one. Error, requested walk segment, has already been removed. This is an indication of a broken replication, because a standby is trying to replay this particular wall file, but it's gone because wall keep segments has already caused the wall file to be removed. Okay, I'm running out of time, so I think the last one I wanted to share with you here in terms of what to look for. This auto vacuum output, like I mentioned earlier, if you have your auto vacuum being logged, the statistics here, you can see that, oh gosh. You can see that at the end of this auto vacuum, 198 rows were removed, 125,983 remain, 99,000 are dead but not yet removable. Why are so many rows dead but not yet removable? This is an indication that they might be locked up in some kind of transaction. So you need to go through your database and look for any long-running transactions or idle transactions, and either roll them back terminate them or commit them. So that way these can be vacuumed away. Because if they're not, then you could actually run into a wraparound issue. So I'm going to jump over to the end. This one has to do with the log lock weights. So as you can see, there's this queue. So if you need to, aggregate the logs and try to analyze them, use something like pgBadger, pgAnalyze. Other applications out there might help you digest the log as well. Finally, I want to make people aware of a very useful tool extension called auto-explain. This one actually adds explain output to your log. And this is very, very useful in terms of helping you identify any kind of performance issues. This extension has really helped us help our customers several times in terms of trying to identify why their plans were slow, why their queries returned in a long time, stuff like that. Okay, so just wrap up. So be sure to set your logline prefix. Use this. Log as much as you can. Use the partition, a separate partition if you have to. And finally, monitor your log for spikes and spikes in fatal error warning and panic messages. And then finally, pay attention to patterns in your logs. And hopefully this will help you guys resolve many of the issues that come up. And if not, you can always look to EDB support, or you can look to any other support organization for help. So I know there's not much time, but if you guys have any questions, please do let me know.
Wow, Richard, thank you very much. Very, very detailed and useful. At least I learned a lot. Meanwhile, no questions, and with your permission, we will post the recording of the presentation in our YouTube channel. Okay.
Great.
Yeah. Thank you very much.
Thank you.
Thank you for joining us during your night. Yes, it's late at night.
Yeah, you can see the window's dark.
Yeah. Thank you. You. And hopefully next year, yes, to see you as well.
Oh, I'd love to join.
Okay, thank you.
All right, thank you.
Right, bye-bye.